So with this situation, we got an insect that can jump at crazy acceleration. Okay, and we're gonna assume it's a constant acceleration of 400 g. That's insane. So let's make the direction the beetle jumps. This is not while the beetle is in free fall. This is while the beetle is jumping. Does that make sense?
Yeah.
So the beetle is in contact. There's my beetle. There we go. It's in contact with the ground and the entire time. And it says, the question says, the certain insects can achieve seemingly impossible accelerations while jumping. Okay, the click beetle accelerates at an astonishing 400 g. So it's jumping up, straight up. I'll make that positive. And this is while jumping. So this is while it's speeding up. This is not while it's in free fall.
Okay.
Because when it's in free fall, when it's not touching the ground anymore, the acceleration is down 9.8 meters per second squared. Okay? And this is happening over a very tiny distance of like half a centimeter. Okay? It's bending its thorax to do this and clicking. This is the click beetle. This is a cool problem. It's real. And we're going to pretend the acceleration is constant. The velocity is increasing and the acceleration is up, and the acceleration is not changing at all. The entire time the acceleration is this 400 g the entire time. Okay? So we got an acceleration graph that looks like that. And this is 400 g. So our change in velocity is 400 gt. Right?
Yeah.
And then our velocity graph would look like this. Bam. And this area,
Change of x.
yeah, our displacement, good, which is our, what is it, 0.56 centimeters, which is 0.0056 meters. Right? I just converted the centimeters to meters. And that's our displacement. And the height of this triangle is our change in velocity, which is 400 gt. Right?
Yes.
So what we need to do then is find the area of this triangle. So 1/2
Times.
and the area has to be our displacement, 0.0056 meters, right? Is going to equal 1/2 400
Times.
gt times t. So I got that? So then we've got I don't know, 0.0056 times 2. No, I'll just do it this way, 200 gt squared. The only thing we don't know is t. You can solve this for t. Once you have t, right, you can go back and plug t in here and use 9.8 here. So 400 times 9.8 times your solution for t from here. And that will give you start from rest, your change in velocity is going to be your final velocity, which is what they want. They want the speed, the speed when it leaves the ground. So that's the speed when this constant acceleration is over. And then when the beetle leaves the ground, then the acceleration is down. And then the next problem, how much time is required? Well, I would actually do that one first. I would do part B. And then this will give you your part A. And then let's see what part C is. Ignoring air resistance, how high would it go? That's a very difficult problem. That's basically now that it has this speed, you got to do everything all over again, but with a different acceleration of just g. And that acceleration isn't up, it's down. and the initial velocity is some value. So why don't you try these two and then come back for part C, because part C is a free fall problem. This is a very challenging problem, very good for you.
Okay.
Try this first. Good work.